So, tonight we're going to be talking about writing, building, and using custom editors in Unity. My name is Ryan Meier. I am a programmer, game developer, game designer. All my contact info is here if you want to get a hold of me. Feel free to email me with questions, stuff afterwards. Email's up there. Blog is up there. I've actually been posting most of this talk as a series of posts over the last week or so, so if you want to go back and look at anything, it's all up there. I'll also post all the source code and stuff after we're done here if you want to check it out and play with things yourself. So first off, real quick, who the heck am I? I have a CS degree from the University of Michigan. I worked for Blizzard for about 2 or 3 years on the World of Warcraft team, and I'm currently working with a nonprofit here in Baltimore. We're doing an interactive game development exhibit over at the BMI to try to teach kids of all ages sort of what goes into making a game and what their place in the industry might be. I've been working with Unity for about 2 years, about a year professionally, and then a year before that just kind of hobby-y. And I'm really big on process and efficiency and automation, which is kind of what drew me to editors in the first place. I kind of like to, I figure if the computer can do something, I'm going to let it do it and not spend a lot of my time doing that work. Sometimes it goes a little too far. You may spend more time writing the editor than you actually do, you would have writing the code, but it's often very handy. So before we get started and get into the nitty-gritty, this is a pretty technical talk. It's going to be a lot of scripting. Editors are meant to be very functional, not necessarily pretty. It's going to assume some familiarity with C# and writing C# code and just scripting in Unity and how that whole system works. I've structured this kind of with simplest to most complex, with some very easy, simple ways to customize things, and then getting into the really complex stuff closer to the end. And the third big thing is that online documentation is definitely your friend when it comes to this kind of stuff. I'm going to go through a bunch of stuff, lots of classes and functions. Don't feel the need to try to memorize it, write it down. It's all online. I use it all the time. Unity's script reference is actually really good. A lot of times, if you're trying to figure out how do I edit a float, it's super easy to just kind of Google it and look it up. So feel free to use that as needed to try for getting stuff out of this. So real quick primer for anyone who hasn't used Unity too much, some of the stuff that we're going to be talking about and is good to know. Game objects are just kind of anything that exists in a scene in Unity, anything in the world. It's just a position, and you can attach mono behaviors or components to that. What those are all your scripts that you're writing. Generally, you can do them in C#, JavaScript, or Boo. I do all my code in C#. I believe most people do everything in C#, so that's what this is going to focus on. The inspector is one of the windows in the editor that generally shows you the information about the currently selected game object and all your components. A field, which I reference a bunch, is pretty much just any member variable in one of your classes. And properties are just something provided by C# to give you, it's pretty much syntactic sugar to add accessors to your fields. So, why would you want to make custom editors? First off, they're really good for organization. When you get components that are really big, sometimes the property list can get pretty long and unwieldy, especially if you're going through, especially if it gets near the end of a project, you're just slapping stuff on. Maybe it's not as organized as it should be. And when you get 20 or 30 properties on there, trying to track the right one down is a pain. They're probably not grouped right, things like that. You can do more than just change a value. You don't just get a text box with the number that you can edit, and you can also add logic to it. These two kind of go together. So if you want to have a float that is an angle, you can do things to constrain it so it's only between 0 and 360, or 0 and 2 pi if you are doing it in radians. Make sure all your numbers are positive, things like that. And the default inspector in Unity can get kind of unwieldy and can be a pain to use. Lists, if you're familiar with using lists, I hate the default editor for lists. I think that I've seen Unity mention on more than one occasion that they also hate it and are working to find a better solution. It's just kind of hard to do a generic one. 4.6 actually has a really nice class that you still have to use in a custom editor, but reorderable list is a really nice editor for lists. You can move them around, add, remove components, all that stuff. So, as I said, we're going to be going from simple stuff into more complex stuff. So first, we're going to look at 3 areas that are very easy, simple ways to kind of customize the way the editor looks, clean it up a little bit. And these don't require much, if any, complex code. So the first one is using serializable classes. So what that is essentially just a simple class in C#. You add the serializable attribute, as you can sort of see in that screenshot there. I have some real code we'll look at in a minute. And you just use these to store your data. And essentially what this does is, hooked up to a mono behavior, it will give you that little collapsible bit you get to see at the bottom. So you can kind of use these as folders to organize data in the inspector. It doesn't take up a lot of overhead, and it just cleans things up a lot. So let's look at an example of that in the editor real quick. So here I have a super duper basic little game. We've got a player object, he's got a move speed and a turn speed, and as you can see, we just use the WASD keys. You can move around, you can turn, you move forward, backward, turn left and right. As you can tell, I'm not an artist. These are very much shapes and colors, and that's kind of how I do a lot of prototyping. So here we can tweak our move speed, crank it up, and he moves super fast. Change our turn speed to 720, and he'll turn about twice a second, things like that. So this particular component isn't terribly complex. However, if this were in a list of 30 things and you wanted to know where are my movement properties, that can be kind of annoying. So what you can do here, if we look at the code real quick, it's pretty simple. We've got move speed and turn speed variables. These two properties here are really just wrappers, so that to make this example work a lot easier, so that the code just references capital M move speed and capital T turn speed. And you'll see when we swap over, they can reference the same variables. Normally you just hit the variables as you would with any normal code. So let's swap it over to using a serializable class to store our player stats. So if we look at the top of this file, we've got this player stats class. It's just got move speed and turn speed, identical to what we had in our mono behavior by default. And then these two properties, instead of just wrapping the variable that's on the behavior, we're wrapping stats dot move speed and stats dot turn speed. That's how you'd access these if you wanted to do them in the actual logic. So then if we go back over to Unity and give that a second to compile, you'll see we have this nice little drop down. Move speed and turn speed are there, and they work just the same as they did before. So if I change that, he goes super fast. If I change this to like 360, he turns a lot faster. So there's one super simple way to kind of customize the editor and clean things up a bit. By the way, if anybody has questions at any point, feel free to just yell out at me. So second, what we'll look at is another way to kind of clean up the editor are attributes. So first of all, what the heck are attributes? Attributes are a feature of C# that essentially lets you tag a class, a variable, a function, pretty much anything with some sort of data that other code can access using reflection. We're not going to go into reflection. Reflection is black magic. If you want to look into it, feel free, but you don't really need to worry about it for this. So that serializable tag that you saw on our class, player stats class in the first example, is actually an attribute. It's one of Unity's attributes they provide. It's called serializable attribute. Who would have thunk it? So Unity provides several attributes that do things to the inspector. So when their code goes through and looks at your class, they find these attributes and they say, oh, I'll draw the inspector in a certain way based on that. So some of them you may have seen. I know I use these pretty early on for various things. Hide an inspector, which takes a public variable and makes it not display in the editor, and serialize field, which takes a private field and makes it display in the editor, and also make sure that the data gets saved as you're saving your scene and things like that, because private variables don't get serialized by default. However, there are also some others that they add that you may not have seen before. Context menu item and context menu are all about giving you sort of right-click menus and options in there to do things with your class. Space adds a space in the inspector between two fields. Header will add a bold header text above a field. That's pretty good for separating out like sections of variables and things like that. Multiline and text area both work with strings. So multiline will cause a string field to always display as a number of lines that you pass into the parameter or the constructor. And text area will give you a range of lines. So multiline you'd pass in 4, and it's a 4-line, actually. It's 4-line text box. Text area you pass it like 3, 6, and it'll start at 3, but once you get to 6, it'll expand up to 6, and after that it'll start to have a scroll bar. Yeah?
So with that space tag, assuming it reads the tag sequentially from top to bottom?
Yes, so essentially the effect of the tag goes before the variable that it precedes. I have some code I'll show you in a second that should explain that. So then range, you can use on floats, and I believe ints. You give it a min value and a max value, and it essentially constrains the value to those. It also causes it to display as a slider with a text box on the side, so that's kind of nice for tweaking values and things. And tooltip, you pass it a string, and whenever you mouse over that variable, it outputs that string. So let's look at an example of these. This guy doesn't actually have any gameplay to it because there's not much gameplay to these attributes, but here is just a bunch of attributes used on a script. So let's grab this. So we can walk through this. Can you guys read that all right? Bump it up a little bit. All right, so just walk through these one by one and kind of see what they're doing. So first, we have this public float that's got the hide and inspector tag. And if we go over to Unity, I don't know if you can actually see this, but this first variable is in fact not hidden variable. It is serialized private variable. So not an inspector causes it to not show up. Serialized private variable here is a private variable that has the serialized field tag. You can see it shows up in the editor. Space, this spaced float has a 30 pixel space above it. If we go into the editor, right here, you can see that's right before the variable. And then range, we have a float. We use the range attribute. We say it needs to be between 3 and 4. And then we can go in here, use the slider to change it. If I set this to like 1, as soon as I get out of that field, it sets it back to 3. Same thing if I go to like 6, it sets it to 4. Then we have a string with a header on top of it. We're getting into sort of string stuff, so figure we label this section text attributes. If we go back over to Unity, you can see this nice little bold header section. There's a little bit of space in there too, so it sets it off really well so you can actually see that there's a difference there. Text area here, we have a 3 to 6 line text editor, or text area. So here's 3 lines of text, and then if I keep typing, it'll expand. But then once I get past 6 lines, it adds a scroll bar and it scrolls up and down. Multi-line text, here we have a 4-line multi-line, and this is just 4 lines in this field. You can see there's actually about 6 lines of text in here, but you actually have to scroll them with the cursor. Then we have integer with a tooltip on it. So if we mouse over that integer, we get a little pop-up, variable is an integer. You put much more informational stuff there. And then this context float, we're using the context menu item attribute on this. So this one, the way it works is that you'll give it a name and then a function name. And when you right-click on the variable, you will see that name, and you can apply multiple of these, so you can have options. And then when you click on it, it calls the function that you specified. So here you can see it spit out 5.65, which is the variable of context float. And if you look in here, field context function, just debug.logs context float. And then the last one is context menu. So this actually goes on a function within a Unity object, and this will add it to the component's context menu, and it just calls that the function that comes after it when you click on that option. So here we just have a simple function that debug.logs again, and then when I right-click on the component itself, you can see there's an extra little option down here. Click on that, and it outputs the text that we put there.
Is that the same for if you would click on it in the editor view, or is that
Where in the editor view?
object in the editor view?
No, they're different menus. Yeah, so this is just on the actual component itself. All right, so that is Unity attributes. So the third kind of simple thing we're going to go over is something called gizmos. Gizmos are essentially ways that you can draw information into the scene view that doesn't draw in the actual game. So if you've seen like the camera or the light icon that shows up on a camera or a light in the scene view, those are gizmos that use an icon. You can also add your own custom ones. So here it's an example with the boxes and the sphere. So the basics of doing this, there's 2 functions you can add to your mono behavior, and these work just like update or start or something. You're not overriding a function, you just put in a function with this name and it gets called at the appropriate time. OnDrawGizmos and OnDrawGizmos selected. The big difference, as you might guess, is that OnDrawGizmos is drawn all the time whenever your object is active in the scene view. OnDrawGizmos selected is called only when your object is selected in the scene view, or in the hierarchy. So selected is really good for, you can display a lot of information that might be kind of annoying if 30 objects were displaying it, but if you want to look at one and get some more detailed stuff, you can do it in selected. OnDrawGizmos is good for showing information that you would want to see when you're actually playing through the game and just debug info, or when you are laying out other objects, things like that. So inside of those functions, you're going to be working primarily with the gizmos class, which has a bunch of static functions and the color property that is mostly what you'll be working with. So gizmos.color is just the color property that you can set and retrieve. Whatever that's set to at any given time, whenever you call one of the draw functions, it will draw in that color. So a block will generally be gizmos.color equals color, and then a bunch of draw calls. And then those draw calls are, you can see a list of examples on here. Cube icons, you can actually draw textures, lines, rays, and the wireframes. So cube and sphere are actually solid. Wire cube and wire sphere are just outlines. Those are generally going to take a position, which is in world coordinates. So a lot of times you'll offset that by using the position of the object to make it actually show up in the right spot. And then defining characteristics for the shape. So for an icon, you're going to give it a texture. For a cube, you're going to give it a vector 3 of sizes in X, Y, and Z. For a sphere, you'll give it a radius, things like that. So let's look at some actual code. So this example here again is a very simple little game where it doesn't look like there's anything going on here, but I have these little invisible triggers over here. There's 3 of them. There's a red one, a blue one, and a green one. So essentially the idea here is that whenever the player enters one of these triggers, something happens. Right now it just debugs a message saying that the player's walked into it. So if we look at this side by side, you can see the triggers are the outlines. And as I kind of move around, if you look on the left in the scene view, you can actually see when he walks into there, it outputs a message that he went into the blue one. When I walk over here to the red one, walked into the red one. So pretty simple gameplay. And then we can look at the code for this. This is going to be the invisible trigger. So this is the code for the invisible triggers. Up top, I have a couple properties that essentially just cache and wrap and grab the box collider and circle collider components on the object, so you don't have to actually define custom geometry for the way the gizmo draws. That's pretty basic stuff. It's just get component with some caching. Then we have a super simple on trigger enter, just output who entered. And then we have our 2 on draw gizmos functions. The only difference between these 2 is that the selected one uses the solid cube and sphere, and the on draw gizmos uses the wire cube and sphere. Essentially all we do is we set the color and then draw a cube or sphere representing the collider depending on what's attached. So one other thing that is going on in here that's just kind of good housekeeping, if you're using any of these static classes that have a dot color property that you set, it's often good to cache the value before you start and then reset it to that when you're done, so that if other people have set it and things like that, it works the way they're expecting. It's often not a problem, but it's just kind of a good practice to get into. It doesn't matter as much for colors, but when you get into things like GUI enabled, it's not good when your GUI code doesn't work because somebody forgot to set it back. Or more likely because you forgot to set it back. All right. So I think that is it for gizmos, and that is about it for the super simple stuff for now. Yep.
Maybe this is a kind of a question, but is on gizmo selected, is that called for children when it's parent selected?
Yes.
Okay.
If anything above it is selected, it's called. So shall we go back over here? You can see that if I select the group that these are in, they're all lit up. All right. So, any questions on the things we just went through before I get into the nastier stuff? All right. So before we actually get into the different types of editors, we'll need to talk about the tools we're actually going to use to write them. So those are all in the Unity editor namespace. So go over the basics of that. First off, any code that uses anything in the Unity editor namespace needs to be underneath a folder in the folder structure that is named editor with a capital E. Unity literally looks for that name, and anything under it is actually put in a separate Visual Studio or mono-developed project. So all of the editor code can reference game code. Game code cannot reference editor code. And that is just set up because if you actually ship the game doesn't have the Unity editor information and classes and all that. So just be very careful about that, and you don't want to use Unity editor in your game classes, just because you won't actually get an error in it as long as you're importing the namespace until you go to build it, and then it'll actually try to build it without all the editor stuff, and you'll get errors, and that's no fun for anybody. One other thing to be aware of, it's generally not a problem, but this was something that has tricked me on a couple occasions. There are two ways to edit data inside of an editor, which I'll get into in a little bit. But if you're editing it manually, you sometimes need to make sure Unity knows that the object has changed, and therefore it needs to save it or save it to a or that data needs to go to a prefab or something like that. So that's done with the editor utility.setDirty function. You pass in an object, so that could be a component, a game object, anything like that. And that just tells Unity, hey, I've changed stuff about this. Be aware of that when you go through your saving process. And I'll talk a little bit more of that later. Again, that's most of the time it's not a problem, but handy function to know exists. So most of the actual editor fields and stuff you'll be writing are going to use the editor GUI and editor GUI layout classes. These work pretty much identically to GUI and GUI layout if you are unfortunate enough to have had to work with those. They're not as bad in the editor, but essentially you will, the functions will be something field, so float field, int field, string field, things like that, or sorry, text field. You'll pass in, for GUI, you'll pass in where you want it to draw and the current value, and then it will return the value post-editing. So this code would be how, if you had a member variable called angle, that's how you would draw an editor that edits the value of angle. The only difference between this and GUI is that it adds some fields that are not used for the normal editor, such as objects, which lets you take in anything that derives from a Unity object, so game objects and components mainly. Editor GUI layout is pretty much the same as editor GUI, however, it handles the positioning for you. So this is really nice. I try to use it as much as possible. If you want to have fine-tuned control over where exactly your controls go, editor GUI is there. Editor GUI layout makes life easy. So you use the begin horizontal, end horizontal, begin vertical, and end vertical functions to essentially say, I'm starting a block of things that I would like to arrange themselves vertically or horizontally. And you have to have a matching end for every begin. So that's can be a little tricky, sometimes hard to track down. I've taken to recently starting to kind of comment each of the begin and end lines with some identifying phrase about what it is, so it's easy to track down when it started and whether or not I've closed it. So another thing that can be handy are the serialized object and serialized property classes. Essentially, these are just helper classes to edit data on some sort of Unity object. They give you accessor functions essentially to change the data, and they automatically handle things like registering for editor undo and redo. They handle the dirtiness of a variable, what I was talking about earlier, automatically. And there's a special function in editor GUI and editor GUI layout called property field, where you can pass in a serialized property and it'll just draw the right editor. You don't have to worry about what type it is. This is somewhat of a do as I say, not as I do kind of thing. I'm really bad about using these, but they're useful for doing this kind of stuff. Sometimes they make getting to the data you want a major pain, so you don't need to use these all the time, but they're very useful and definitely a should use if you can. So using these guys real quick, initialization of a serialized object, you just pass it the object you want to be able to edit. So you just use new serialized object, and then my component will be the reference to the mono behavior that you're trying to edit. So within serialized object, you can get access to any property on the object by using the find property method. And there you pass in literally the name of the variable. So in that first example where we had move speed on our component, if we were editing that, we would do serialized object dot find property and then in quotes move speed. And that returns a serialized property. Inside of there, you have a couple of variables that are useful. Dot property type or dot type are a way to get what type of data is stored inside the serialized property. Dot isArray array size and array element at index are how you manipulate arrays. If it's a list or an array of something, it'll tell you if it's an array how big it is, and array element at index gives you the function or the element at that index as a serialized property. Dot some type value, so that's going to be dot float value, dot int value, things like that, are how you actually access the data, both getting and setting. And then dot find property relative is if you have a serialized property that is itself a class that has variables. You use find property relative just like you would find property if it were a serialized object. All right, so there's three main types of custom editors we're going to talk about today. The first one's property drawers, which you can use with either property attributes or custom classes like the one we talked about in the first example. There are component editors, which are what you use to edit anything that derives from unity.object, generally mono behaviors, but there are other things you can use them for. And third is going to be editor windows, which is just a window that you can do whatever the heck you want with. So first, let's look at property drawers. So what these let you do is they let you specify the editor behavior for a specific class or for a property attribute, which we'll talk about in a minute. It's automatically invoked for that type in the inspector. You don't have to actually write a custom editor for every behavior that uses that variable. You can just say, for every player stats, I have a property drawer that draws it a certain way, and that will happen whenever a player stats is attached to something, and the default inspector hits it. So, the basics of actually writing one of these, you want to make sure it's in that editor folder we talked about earlier. The class itself needs to extend the property drawer class, which is part of Unity, and you'll want to put the custom property drawer attribute at the top of the class, like we did with serializable, and you pass in the type that it should edit in the constructor. So if it's an editor of type, or if it's an editor for player stats, you pass in type of player stats to the attribute. Then inside of the property drawer, you'll override the onGUI function, which is where you actually draw all your GUI code. And then you can, if you need to, override getPropertyHeight, which just tells it how much vertical space you're taking up in the inspector. You'll need to worry about that if you're using more than what would be default for the type of field you're looking at. Generally, that's one line, but it depends on the field type. So one thing of note here is that GUI layout and editor GUI layout don't really play nice with property drawers most of the time. Essentially, if the property drawer is being drawn from something that has a custom editor for it, the layout functions work. If it's being drawn in the default inspector, the layout functions do not work. Essentially, the reason for that is that they don't work. The custom editors have essentially a begin vertical and end vertical wrapped around the function that you get. That's not the case in the default inspector. So this is the one point where I advocate using GUI and editor GUI instead of the layout versions. Everything else, I think layout's just way easier. So let's go ahead and take a look at a property drawer. Swap over here. Here I have written a simple little serializable class called boolvector3. It's just essentially a vector3, but instead of floats, it stores booleans. So it's got public XYZ, simple constructor with the default values, and you can pass in variables, and then a component that just has a public version of that so you can see what it looks like in the inspector. All of the exciting stuff shows up in boolvector3 drawer. So here we have this custom property attribute tag. We tell it that this is a property drawer for a boolvector3, so it knows what to draw it on. And then in this onGUI function, you get passed a serialized property that is the object that or the field that you're looking at. So in this case, it's this vec component. And then so from here we grab the X, Y, and Z properties on there, and this is just the reason that you can pass in labels to the various field functions by default. Laying these out this way, labels with toggles are a little weird, so I did the labels manually in this particular case. But you can see each of these fields, you just pass in a rect representing the space you want it to take up. You get passed in essentially the rectangle that the inspector has given you to work in, and you can use that. You can actually draw outside of it if you want to, but then things get really messy. So this essentially just draws the three variables in line with labels. And then getPropertyHeight was not actually needed for this, but there's an example of it. And if we go into Unity and take a look at this component, you'll see that we just have three checkboxes for X, Y, and Z. Normally, here we go, phi. So if we want to see what that looked like without the custom editor, we can go ahead and just do. So yeah, in any of these onGUI functions, you can always do the base dot onGUI or onInspector GUI to have it draw the default inspector for that. That's useful if you want to just kind of add things at the bottom, stuff like that. So here it's actually going to draw both because I just added it above it. And once that compiles, That's ugly. Let's get rid of this. Now that's because it gave me a rectangle and I drew in it twice. Did that not save? Come on, buddy. File, you can do it. GUI implemented. All right, never mind. Let's not look at that. Would look like default. So that's the basics of the property drawers, and we'll use these again in a little bit when we get to property attributes. Any questions so far? All right. Next up, we're going to look at property attributes. So these essentially allow you to specify editor-specific constraints to a certain field in your class. So this is essentially like the stuff we looked at earlier with space, multi-line, range, but you can actually write them yourself if you want to. So basics of this does not go in an editor folder. This actually goes in your normal script area. It should go in the project that ships with the game, because this will actually go in, be attached to your mono behavior. You extend the property attribute class. I forgot to put it on the slide, but the name of the class should be the name of the attribute followed by the word attribute with a capital A. So that's actually how it looks for it when you're writing it out. So the incrementable you see here, the class name is incrementable attribute. Same thing with serializable, it's serializable attribute. The constructor is actually what's getting called inside of those parentheses in the braces, so whatever you want to get passed in gets passed in there. And all the display and logic of these actually gets handled by a property drawer as far as the inspector is concerned. In a minute. So I actually have two examples for this guy. We're going to look at first an attribute to essentially constrain angles to one rotation, so that you don't have a 920 degree angle. You have whatever that is within one rotation. So first, the angle attribute class is extraordinarily simple. This is not where most of the fun stuff happens. I just have angle attribute. It extends property attribute, and we have one read-only variable that just says, are we working in radians or degrees? And the constructor just takes a Boolean and sets that. Then in the property drawer, this is where the fun stuff happens. First off, we essentially grab the value of that angle attribute that is attached to the object we're looking at. So this is, again, just a wrapper for that. It provides it as the attribute variable of the property drawer, and that's just a base property attribute. You actually need to cast it to your attribute type to get the data that you probably want. Then again, we're overriding the onGUI function, which is pretty simple. We use the property that they give us, which is already the float, and we draw a property field for it, so we don't actually care what it looks like. And then we call this clamp angle function on it, which takes in that serialized property. If it's null, returns. We determine what a full rotation constitutes. So if we're working in radians, it's going to be 2 pi. If we're working in degrees, it's 360. Let me beef this up a little bit. And then essentially, as long as it's below 0, we crank it up above 0. As long as it's above a full rotation, we crank it back down. So coming out of this, an angle should always be between 0 and 1 full rotation. So then, actually real quick, let me grab the component for this too. So using this, again, we just declare a float, and then we put this angle attribute on it. The first one is in radians, so we pass in true. The second one is in degrees, so we pass in false. And then if we go over to Unity, take a look at this object, see we have a radians angle, and if I try to crank this down below 0, it's going to wrap right back around to 2 pi. And degrees, same thing. If I go down, it goes up. And then if I try to go back above 360, it goes back down to 0. You can also do fancier stuff with these. I've seen angle drawers that are a knob that you can turn, and it actually is a graphical representation of it. It's a little more complicated than I want to get into here, but that's interesting. Feel free to look into it.
Is that just an image? Is that a sprite that they do? Or?
Yeah, it's just a texture that they draw and rotate. All right, so then the second one of these we're going to look at, which is enforcing a little more actual interactive logic, is what I'm calling incrementable. So grab these two files, incrementable So again, the attribute is super simple. Essentially, what incrementable is we want to say that this number can only go up or down in delineations of an increment of some amount. So we pass that into the constructor, and then we store that on the attribute itself. Then inside of the drawer, again, we grab the attribute, cast it to the attribute type we want, so we can actually get the data. And then on GUI, this actually is where most of the fun stuff happens. So first, we essentially just store off what direction we are going to be incrementing in. It starts at 0. So this is just to keep track of the states from the buttons that we get back. Button width is just a property to determine how wide the buttons are. Then we're going to draw 2 buttons, one on the left and one on the right. The left one's going to be minus our increment. We get that again here by the attribute we have, dot increment by. And then same thing with plus, we do the exact same thing. And essentially, if we click the left button, we say increment direction is -1. If we click the right button, we say increment direction is 1, so we want to go up. Then, this is where we actually use the property type value on the serialized property. So this works with either floats or integers. If we look at this, we say if it's a float, set its float value to, or add the increment value times the direction that we figured out to its float value, and then we just grab a string so we can display it. And vice versa, or same thing with integers, except we actually cast it to an int and assign it to the int value. And then we draw a label with the actual value of the variable. We don't actually want to use an int field here or a float field here, because if we do, then you can just edit it willy-nilly and break everything that we're trying to do. So if we look at this, actually let's look at the component real quick, sorry. So here we have 4 of these. We have an incrementable int and an incrementable float. So the default value in the constructor over here is 1. So passing nothing in, it's going to increment by 1. Then we have an int that goes up by 3 and a float that goes up by 4.5. So if we look at this in Unity and take a look at this object again, you can see this first one, we have -1, it goes down by 1, +1, it goes up by 1. Same thing with this float. And then the integer goes down by 3, up by 3. The float goes down by 4.5, up by 4.5. Yeah?
You might have mentioned this, but the onGUI function for yours, there's 3
Parameters?
parameters that it's sending in. The middle one's obvious. What exactly are the other 3?
Sure. So the position is essentially so if you saw that, like, all the GUI and editor GUI functions take a rectangle as their first parameter that tells it where to draw. This is essentially saying, within the inspector, this is the rectangle that I'm giving you to draw in, and then you just use that as your basis of where to draw. So essentially, if this is 300 pixels from top, you're getting a rectangle that is however wide the inspector is, 300 rectangle down, or 300 pixels down, and however tall the field is.
Probably not too useful unless you manually position things.
Yeah, so again, on GUI here, you generally want to use the GUI functions. Yeah, you won't use that if you're using the layout. You just completely ignore it. Oh, the last one. So that is the default label that would go. That is the label that it would have in the default inspector. So it's generally the variable name. So this label, actually, I don't want to output it. So that label for this one would be incrementable float, incrementable int by. Actually, oh no, I think I'm cheating and using the property value on that, but I think this would be pretty much identical if I used label.
So you can change the name of what you see in the editor if you want to.
Yes. Well, so this isn't actually even drawing anything. It's just telling you this is the label that I would put on it if I were drawing this.
Okay.
So, like, you can see here the label that I have, the actual string value that's getting passed, I'm grabbing the name off the property and then printing the value of it. I don't actually use label in this function. I probably should, but that's just in case you want to label it the way it normally would. It's probably a good idea. But again, it all depends on how you want to display it. Any other questions before we move on? Cool. So next, we're going to talk about component editors. So this is essentially a way to completely define custom inspector for any object that, or yeah, anything that derives from unity.object. Most times this is going to be mono behavior or a component. And essentially what this is you're saying Unity, back off. I'm going to do this myself. Don't draw anything for me. The basics you need to know for this. Again, it needs to be in one of those editor folders because it is editor code. The class that you make is going to need to have the custom editor attribute on it with the type that you're trying to edit. Same as with property drawers. There's the can edit multiple objects attribute, which by default, a custom editor will only be able to edit one object of that type, or one object at all. If you give it this attribute, it will allow you to edit multiple. You interact with it slightly differently when you're doing that. We'll get into that in a sec. But if you want to be able to edit multiple of the same object, you just make sure you add that attribute at the top. The editor class should extend editor, capital E, and the main function you're going to be working in is this onInspector GUI function. And that is actually an override from editor. It's not just like the gizmos thing. Notable properties to worry about or to know about are the target and targets, which are on editor, which is essentially the object that you're editing as a Unity.object. So you still need to cast it to the component type or whatever you're working with. And they actually, as of I think 4 point something, they give you a serialized object version of that. So they pre-wrap it. They call a new serialized object for you and pass it. You can get it as this serialized object if you want. So we'll dive into an editor for this. Here we have this a little more in the scene view. So here we have a super simple little game. Essentially, there's this little tile grid. There are 4 different types of tiles we can have. White is empty and pathable. Blue is where the player starts. Green is the goal tile where you're trying to get to. And red are walls. Obviously, this level is extraordinarily difficult. You just use the arrow keys to move around. When you get to the end, it spams you with you win. So the code for this, you can look at how get rid of all this other files. So look at the game board component. First off, we have this tile prefab object. This is just an easy way to store. Sorry, let's look at the enum first. So we have an enum with the different types of tiles we can have. Again, empty, wall, goal, and start. Then we have this tile prefab class, which is just a way to pair a tile with a game object that will be the visual representation that's a prefab that we spawn in to make the board. Then in the actual game board, we have a reference to the player object. If this were a real game, I wouldn't advocate doing all the logic inside of the board class. This is a really small example, so I do that. But this is just to know what to move around. Then we have these size X and size Y fields. They're both private, serialized, but hidden in the inspector. And they both have wrappers, capital S size X and capital S size Y, that essentially let us know when the size is changing and react to it. So in this particular case, we are storing the list of tiles as an array, and whenever the size changes, we need to manipulate that array so that it's the appropriate size. So this just lets us say if the size is actually different whenever size X gets set, we just call resize tile array, and that resizes the array of tiles that we're working with to the appropriate size so we can actually store as many as we want. Then we have tile size, which is just a lazy way of telling it how big each tile is in world space, so it knows how to space them out. Board size is just a wrapper to get the world space size of the board that it's going to draw. It's relatively irrelevant, actually. And then we have these 3 lists, only 2 of which are actually that important. Tiles is just a list of that enum that we were talking about before that represents the actual board and what each of the tiles are. It's one-dimensional because Unity doesn't like serializing 2-dimensional lists. So we just essentially access this. For all intents and purposes, the index of any given xy is x times size y, or size y plus y. So we're just essentially taking the 2-dimensional array and stretching it out. And yeah, this just kind of keeps track of as we're going through the board, looking for where the tile the player starts in, and keeping track of where the player currently is. So since we store this as a 1-dimensional array, If you think of trying to edit this in a traditional editor with the list editor in Unity that I hate so very much, you would just want to die, because you're editing a one-dimensional list. You have to figure out the indices in your head, and you're like, oh, I want to edit 6-3. Well, that's 6 times. You don't want to do that. So let me see if I can turn off the custom editor so you can actually see what that looks like real quick, because I had so much luck with that last time. Base, vector GUI. So if we look at this game board, yeah, here we go. So this is super ugly. You don't want to edit levels like this. You would never ship a game. And also this, the tile prefabs list, this is workable because there's only 4 of them, but it's still kind of a pain. And you have to, if we look at an empty one, that list starts empty. That list will by default start empty. I forgot this actually used the custom editor before. And ideally we'd want to say that you have 1 element for each board type, no more, no less. So enter custom editors. So here we have our game board editor, which again we have this custom editor attribute. So we say, whenever you see a game board, I got it. We'll handle this. Don't worry about it. This GUI style, feel free to ignore. That's just some hackery. Inside of this class, we keep track of essentially what the current tile type we're putting into the board is. So if we're clicking on a tile, what do we want to put there? Starts at empty, and we'll set that in a minute. We use that target component I talked about earlier, target field, to grab the game board component that we're actually looking at. We go through and just do some basic initialization on it, make sure that none of the arrays are null, anything like that. And then we go through for every possible tile type and make sure that if our list of tile prefabs doesn't have an entry for that, we add one with a null game object reference, but there's one in there, so we know we need to fill that in with a visual prefab. Then we add an object field for the player. So actually, talk about object field real quick. So this is probably the most complex field you'll have to deal with, since it's not just 2 parameters. Essentially, with this one, you pass in a label like anything else, and you pass in the current value like anything else. Then you also have this type parameter, which essentially is the type that it should constrain the input to. So game object is easy, so you can get any game object. You could put in a component type, and it will also accept anything that is a child type of that. So if you had components that inherited from each other and put the base component in this type filter, it would allow any of the children in. You could put component in here, and it'll let any component in, things like that. But that's nice that if you want to make sure that if you were attaching a player that had a specific type of player script on it, you could ensure that this only accepted players of type player. And if it didn't have a player script, it just wouldn't even hook it up. And then there's actually one more parameter that I think just defaults. Yeah, so then there's also this allow scene objects parameter, which I don't have in here, but I'll add it because it's easy. Essentially what that says is, do you allow objects that are currently in the scene to be dragged into this slot? So this, again, this field is this player object we're looking at. So it's just like a standard a standard game object field. And sorry, spoilers. So if this last parameter is set to true, you can drag objects from the scene in. If not, it won't accept anything that is an object in the scene. Most of the time when you're working with components, scene objects are fine. That would normally be false if you're dealing with assets that aren't like an object in the scene, but sort of like not a prefab specifically, but something in that order that's an asset that's being stored not as a currently active object. And I'll talk about custom assets in a bit too. Okay, so next we want to go ahead and get all the data for our board. So since we told Unity, hey, we got this, don't worry about it, it's not giving us any fields, so we need to make sure we get all the data we need. So we grab size X and size Y, we wrap them in a begin horizontal and horizontal so that they're on the same line. Just makes things cleaner, not entirely necessary. Then we want to grab that tile size so we know how to space out the board with a vector2 field. And then for each of these tile prefab objects we have in our tile prefabs array, we draw an object field to specify the game object. But we give it as the label the key of that, which is the board tile type. So this, you can't actually edit the board tile type of any of these. You can only edit the object that goes into it. So again, if we look at that in the inspector, we have size X, size Y next to each other. Tile size is a vector 2, and then we have those 4 fields. But again, you can't actually edit the names. You can only put a prefab in there as the object. So next, we're going to go ahead and add in an editor for that selected tile we talked about, so that we can pick what we want to add to the board when we click on something. So we just go through each of the values in that enum, add a button, again, all wrapped in a horizontal begin and end, so that they lay out horizontally and not vertically. And this thing at the end is that selected button. If you saw it up top, essentially it's just saying if the button that you're drawing is the currently active one, draw it as a pressed button instead of a usable button. And you can see that here. It's just whichever one's selected, it looks like it's been pressed. Just a little hackery to make buttons look like toggles. And then we actually draw the board itself. So we just go 0 to size X, 0 to size Y. For each of those, we draw a button with the current value of that tile on it, and specify the width and height so that it's uniform across the board. And then we set, if we click on that button, we set the tile value of that XY coordinate to whatever selected tile is that we picked up top. And the generate board is just what actually takes that and puts it into the world. So this is what the editor looks like. We've got this menu up top that lets us pick what we're currently painting with, if you will. And then we can click on any of these and it'll change the value. And then if we click generate, it doesn't work. Oh, because we don't have any prefabs filled in. Sorry. Let me look at the board that's actually doing things. Go away. Sorry, so this is the board that's actually got some stuff going on and the one that's currently being drawn. So here, if we want to add in a wall in the center to like triple the complexity of this, we can do that, and then you can see the red thing shows up. So we have an extra wall. If we want to make this bigger, we can make this 8 by 8, and then it sort of retains what's already there. And then we can go through here and add in more walls and maybe take out some walls, etc., etc. So this is, I think, much nicer than that list we looked at earlier. And it's sort of a graphical representation of what the board looks like and much easier to wrap your head around. So I believe that is the basics of custom editors. Any questions up to this point? No. Yeah?
This might be better for you, but and you may have to help me. A lot of this is very much tied into the current Unity GUI sort of system that they have. Is there any talk of that changing?
This I do not believe will change.
I'm sorry?
This I do not believe will change. I think editors will continue to use the script-based stuff.
I would think so.
Yeah. Scene GUI is way better, but it's the same. Yeah, editors will stay the same. All right, so the last big major topic as far as editors go that we're going to cover are editor windows. Essentially, these are, if you think about let's look at Unity for a second. So the scene view, the game view, the inspector, the hierarchy, these are all windows. They're all probably derived from editor window. And you can move them, you can dock them. Essentially, they just give you a window, you can draw whatever the heck you want in it. So down here is just an example of a dumb little editor window I made to show you what that looks like. So again, basics for making one of these, you need to be in an editor folder, just like any of our other editor code. You want to extend the editor window class, pretty standard. You'll override the onGUI function. You can use the layout stuff in these though, that actually works. Then one piece of trickiness is that in order to instantiate it, you use the getWindow function and you pass in the type of the window that you're making. Essentially that lets Unity make sure that there's only one instance of it, or if there's already one in existence, it won't spawn another one when you try to access it from the menu, which we'll look at in a second. And then you can use the selection class to get things out of the editor, so you can say selection, I think current selection is what's currently selected in the hierarchy. So you can actually use your window to edit things that are going on in the game. So let's look at another example. This time, so essentially what this is going to be is I took the editor from here, but abstracted it out into a window. So let's look at these two guys. So to make this easier, because I don't think we want the standalone editor to depend on a specific game object that it's working with. I made this game board data class, which is got all the game board related code identical to the game board component we made earlier. It's just its own standalone class, so we can save it. And game boards know how to take one of these and turn it into, put all the data into themselves in the world, and these know how to take a game board component and extract all the data out of it. But again, pretty much identical to the other guy. But what this lets us do is that if we look at game board editor window, so essentially, data-wise, we just have an instance of that game board data, so we can keep track of that and what we're editing, what it looks like. And then we have our selected tile just like the other editor. This create window function is what I was talking about a minute ago. Essentially, so editor windows don't draw anywhere by default. There's nowhere for them to exist, so you need to somehow give people a means to get at them. Generally, it'll be done using this menu item, which essentially just adds an item to one of the menus inside of Unity. So that's actually going to be these guys up here. So if you look window, we have game board editor. Essentially, yeah, so you just pass in a name. Slashes will be draw flyouts, not flyouts, whatever the little arrow thingies. And then at the end here, this allows you to specify hotkeys. So this one, I believe, is Alt-G will bring up this window. I'll go into those a little bit more in a little bit. But essentially, this just says, when you click this menu item, call this function, and this function just says, grab a window of game board editor window. If one exists, it'll give you that. If one doesn't exist, it'll make a new one and give it to you. All right, so let's look at the editor here and walk through the code at the same time. That's not it. Game board editor. All right, so here's our editor. Again, we can move it around, we can dock it, we can lose it. Cool. So I can dock it in here if I want to. Kind of cool. Again, we have our size X, size Y. Oh, sorry. Let me actually walk through the editor code here. So you can see here we sort of have like a sidebar with our board data and sort of tools, and then on the right side we actually have the editor itself. So that is pretty much just all of the code is wrapped in a begin horizontal, end horizontal, and then when we draw the sidebar, we do a begin vertical, where's the end vertical, and then when we do the editor, we do the same thing, we wrap it in that. So here, if we look at the sidebar, we specify a width so that it only takes up so much space, otherwise they'll be about equal sized, and I don't think in this case we need the size X and size Y taking up half the screen. We do our size X just like or size X, size Y, just like we did before. We add in two new features that weren't in the other editor, fill and clear. Essentially that just, fill is the paint bucket, whatever you have, it'll fill the whole thing with it, and clear will clear the whole thing out and set it to empty. Then we have a save to object and load from object buttons, which here we use the, where is it? Sorry, I actually grabbed it up top. So here we use the selection class to say, what's the current game object that's selected, grab the game board component on it, and then later on, if it is not null, we use GUI.enabled to say, activate these buttons or just deactivate these buttons. So the GUI.enabled works just like the gizmos color thing. Whenever a field's drawn, it will either be enabled or disabled based on what the current state of GUI.enabled is. So here we just say, if there is a board on the object we have selected, we enable these buttons. And these buttons just let us either take our data and dump it to that board, or grab the data from that board and load it up in this editor. So we can take a look at that real quick. So here's this editor. See, I don't have anything selected, so these two buttons are grayed out. If I click on them, they do not do a thing. And let me fly this so that we can actually see what's going on in the game too. Then if I select this board and grab this editor again, they lit up. And then if I click load, it'll grab the data, and you can see there's full all over here and all this good stuff. And then if I, let's say, add some walls along the right side, and then click save to object, and then regenerate the object, there's a wall there. So you can write back and forth. And then I think the editor code over here is pretty much identical to what we saw before. Again, it's just a new vertical block with all the stuff we did before in it. So one or two other cool little features that we can add in here are, if I uncomment this, so the fill and clear are nifty But I think a lot of times when you're making walls, you might want to do a whole row or a whole column. So here, what I'm adding in this guy here is just a column before we actually start drawing the board that just adds buttons with a caret. And if you call that, we call this fill row function, which just says for this y value, set everything in that row to the selected tile. And in every row, we add a button at the top that points down and says fill this column. So again, we swap back over here, give it a second to compile. We have these fun little buttons. If I wanted to put walls along the bottom, I can do that. Save the object, regenerate it, and now it's got walls along the bottom. So editor windows are great for all sorts of things. Level editing is nice if it's simple and data-driven like this. I've used these for windows that will take certain parameters and spit out code. There's all sorts of uses for these. The editor is your oyster. I think that is about it for editor windows. So those are the big sort of custom editor things when it comes to writing stuff. I do have a few other things I'll go through that are kind of tangentially related, but just kind of useful in the same vein. So first off, talk about menus and how you can add things to them and use them. Just a few attributes you use on things. Context menu, which we already talked about briefly earlier. It's an attribute you add to a function on an object. Whenever you see it in the inspector, you can right-click on that object. Click on that, it'll call the function. If you want that to work when the game is not running, make sure that that function has this execute in edit mode attribute on it that just tells it, hey, this function's cool to execute when the editor's running but the game's not. Context menu item, again, we looked at that briefly before. You pass it a name and a function name, and it'll give you that context menu on the field itself. Menu item is the same thing that was in the editor window, where that adds something to the menu up at the top of the screen. Again, slashes will give you submenus, and then you put that above a function. And then within those, you can add hotkeys for those, essentially using these modifiers before it and then a letter. So if you do %, it'll be control, and then whatever the letter, pound, it'll be shift, and it'll be alt, and then underscore is with no modifier. So you do have to have the underscore there, even for a normal key, though. Another nifty little feature are called handles. They're very similar to gizmos in that they draw in the editor or in the scene view, but not in the game. But these are actually interactive. So if you think about the position drag you get to move an object around, or the rotation, anything like that, those are handles. They go in a custom editor script, and the kind of things you can do with them, you can make a 3D button that you can click on. You can label things just in the scene view. There are some other built-in ones. Pretty much anything like these that you see in the editor, they have handles has a function for it if you want to do something similar. So let's take a look at an example of this. So here again, we're going to be editing that same game board class. I extended it with a version called game board handles just so that the initial version didn't need all this code, but as you can see, it's completely empty, so it's identical. This editor is, again, an extension of game board editor, so that way it inherits all the code that game board editor has, and then we just add some stuff to it. So since we're working in the scene view, clicking on buttons to select the tile we're looking at is kind of annoying. So here we can look at, we can use the event class to essentially say what type of event is causing the inspector to draw. And if it is a key up event, because the key was just released, we can look at what type of key it was, and then there's just a couple hotkeys in here that will swap the selected tile type based on that. And then we just draw the basic inspector GUI from there, and that draws all the code we looked at earlier. Then we have this onScene GUI function, which is what actually does the handles. I don't believe there's an onScene GUI selected. I think it's just onScene GUI. And handles, again, work very similarly to gizmos. They're actually like a combination of gizmos and GUI or editor GUI. So again, you set the color just like you would normally. Grab the current color and replace it at the end, just to be a good citizen. And then set the color to whatever you want. In this case, I've just got like a gray. And then we iterate over the board, and for each of them, each tile, we're going to draw a handles button actually in the world, so that we can edit the layout of the board inside of the scene view. And then essentially, if we click that, we set the tile value to whatever is currently selected. If we go in here and open up this scene, when we look at this game board, you can see there should be some extra little stuff. So yeah, it's really hard to see, but you can see if I mouse over these, they're kind of, you can see one selected. If I hit these, hotkeys are being dumb. But if I have wall selected and I click, it actually changes it in here. So this is a nice way you can do level editor stuff actually inside of the scene view if you want. And these are all actually 3D, but sorry, these exist in 3D. These are all using 2D components, however, so not able to see it here. But yeah, if you wanted to finish off this level, just tap a goal in there, and it's kind of handy. Next, another thing we'll look at is asset processing. So this, I think, was briefly touched on last time. Well, not touched on, but mentioned. So this essentially allows you to modify the way that assets get imported into the editor. So there are some things that you can't mass edit. I think sounds are a prime example of that. You can only edit them one at a time, which is a major pain if you have, you don't want all your sounds to be 3D because your game's 2D. Going through and doing that by hand on 200 sounds is a pain. So there is a class that you can extend called Asset Post Processor, which essentially gives you means to either post or pre-process audio, textures, models, and I think one or two other things. Again, all the documentation's online, super handy to reference that for these specifics. So pre-processing, you'll get a function called onPreProcess texture audio model, and this is actually before Unity grabs the file and pulls it in. You get an instance of asset importer, which is like some of the other stuff we looked at. It's the base asset importer. You'll need to cast it to whatever you want it to be, so texture asset importer, audio asset importer, etc. And you also can reference the path of the asset you're looking at. So that's the actual path in the folder structure. So you can do things like, if you have a sound effects folder, you can import your sound effects one way and your music a different way, which is actually the example we're going to look at in a second. So this is where you're going to want to do a lot of your import settings, as this is when you're importing them. And then post-processing essentially says, I've just imported this, would you like to do anything to it before it gets used? Here you get on post-process, texture, audio, model, etc. And you actually get passed in the object that it just imported. So that's going to be a texture and audio clip, etc. And you also have the asset path here, so you can do things based on folder. So I have a quick example of this. Let me actually pull up this project in the editor in Explorer here. And then here. And actually, this is good. All right, so let's look at asset post-processing. So I have two asset processors that I made here. The first one is a sound effects processor because we are right. So this is an audio processor. First off, for music, if it's kind of ambient music that's just playing on the player, we don't necessarily need it to be 3D, and 3D audio just takes up more computation and stuff. So we want to set 3D to false. And then for sound effects, we want to decompress them on load. I specifically ran into this with a project where I wanted to draw the waveform of a sound as it was playing. In order for that to happen, you need it to be set to decompress on load. So if we look at how a sound would import normally, if I just grab one of these MP3s and drop it into this import assets folder, which doesn't have any processing on it, default, it's a 3D sound compressed in memory is the load type, and these are the default settings. So this audio importer essentially looks at the asset path of the file, for any file we're importing, and says, are you going into a folder that has the word music in it? If so, set 3D to false. Are you going into a folder that has the word or the phrase SFX in it? If so, decompress on load instead of be compressed in memory. So if I go in here and drag one of these sound effects into this music folder and miss, that didn't actually import it. So it doesn't work if you move things from folder to folder. However, it does work if you get it in the right folder the first time. So here we go. If I drag it in the music folder and we look at this, you can see that 3D is off. But if I take that exact same file and import it into any other folder, 3D is on, right up here. Same thing with sound effects. If I take this file and import it in here, it's compressed in memory. And then if I take that exact same file and load it in the SFX folder, it's decompress and load. So that's pre-processing, useful for kind of batch processing, these kinds of settings that you want to do that you can't do in the editor easily. Then I didn't have any great real-world examples of post-processing anything off the top of my head, but just as an example, we're going to do a texture post-processor. So you can see we have on post-process texture, get past the texture 2D, and if this is going into a folder called tint red, we're going to go through all the pixels of that texture and make them red, or make them redder. So if I go over here and grab a texture, and I'll import it again into this base folder, you can see it's just a white circle with a black border. But if I get rid of it and then import it into this tint red folder, it's red. So again, you can. Those are the basics of it. I think these are more of a specific case kind of thing. So hopefully that at least gives you a baseline on how to work with those. All right, got one or two more things. So editor skinning. This essentially just lets you customize the look of the editor. It's not super prolifically used, but if you want to, you can. There's three major sort of classes that you'll deal with when doing this. GUI style is a class that essentially specifies how a certain control looks. You can pass those into pretty much any editor GUI or GUI call as an optional parameter. So when I was doing the button thing to make it look selected, if it was activated, it was passing in a custom GUI style that just grabbed the button pressed graphic from the GUI skin. Within GUI style, there are several GUI style states: normal, on active, on focused, on hover, and on normal. Those are just the different states the controller can be in. So normal is normal, obviously. Active is, I think, when it's pressed for a button, so things like that, when it's actively being used. Focus is when it has focus, so it's selected. And on hover is when you're mousing over it. And then inside of GUI style state, you have, I believe, you have an image and a text color that you can set for each of those states. And then there's GUI skin, which you can work with, which essentially is just, you can access GUI skin.skin, which is the current skin that's being used, and you can use that to set the look for all of the controls by default. So if you set GUI skin to something, or GUI skin.control to a specific GUI style, all controls of that type will use that style. You don't have to pass it in on a control by control basis. All right, I think there's two more things, and then we're done. So another thing that can be useful when we're talking about editors and things is being able to store data in files, being able to write files to the system. If you don't want to store all your levels as prefabs, when it's something simple like an enum, you could just do that in a text editor. Again, yeah, very useful for levels, for things like stats on enemies. If you just want to be able to import those, export those, it's nice to be able to edit them in a text editor. You can hand that off to a designer. They don't have to have Unity or something. They can just tweak things. Excuse me. So the main things that we'll be working with here are going to be system.io and several of the serializers that come with C#. Again, this is all actually C#, but it's useful, so I figured I'd touch on it at least. Useful functions are the file.exists will tell you whether or not a file exists. The file stream class is just essentially how you'll read and write from files. You pass it in a file path, and then a file mode, which is just an enum that says how you want to deal with the file. That's generally going to be open or create, and create. Create says whether or not this file exists, make it. Open or create says if it exists, open it. If not, make a new one. And open just says open it. If it doesn't exist, don't do anything. And when you're working with those, when you make a new one, it'll open the stream. You just need to make sure to close it so that it actually writes everything back. And then XML serializer and binary formatter are two ways that you can actually serialize things to and from files. There are other options you can write directly to them, but these are kind of handy, and they work pretty well with anything that Unity can serialize. XML serializer generally works with that as well. So if you have a mono behavior, you can just generally dump it to a file using XML serializer and read it back. For those, you use the .serialize and .deserialize functions on the serializer itself. They each take a file stream to tell it what file to read or write from. And in the case of serialize, you give it the object to serialize. And in the case of deserialize, it returns an object of the base C# type object that you then need to cast to whatever you want. So, once again, using Gameboard as an example, we have some file I/O. So, here I have once again extended, made a new version of the Gameboard editor window, and the only difference is I added, changed where it goes, and I added 3, I believe, controls. Yeah, so there's this file parameter, and the save to file button, and the load from file button. File just specifies what the file is you want to look at. You can put in a file path. And the root of this is the root of your project folder, not assets. So here, if I wanted to save game boards, I can do board/Gameboard. And then make this a 5x5, put in a couple walls, and then click Save to File. Look at the code for this in a second. But if we go into here, you can see it created that boards folder, and then there's that, here's that note that I just deleted. Let's save it again. So here's that game board, and then if I go ahead and open this guy in a text editor, you'll see it just dumped out the raw data. And then if I go back in here, make some more changes, maybe make it a 6x6, and then load from file, it'll go back to what it was. So let's go ahead and look at how this actually works. These are just, where's the file stuff? So the editor itself is just using this helper class that I wrote, and I'll include with the source that we'll look at in a sec. It just has a write object to file method, which takes a file path and an object, and a serializer, which again is in file helper. And it just writes that to the specified file, load from file, returns the object from that file. Again, we're doing the GUI.enable check to see whether or not we can load if that file exists or not. So we can look at file helper real quick to see how this actually works. File exists, again, just does file.exists, see if it exists or not. Create directory if it doesn't exist. If you try to load a file or create a file somewhere that there is no folder path to, it will blow up on you. Unfortunately, it doesn't just make it. So this file.directory, you can get a file info from a file path, which is essentially just saying, here's a path, give me a way to manipulate it, and C# kind of figures out some other stuff for you. And then this directory.create, it won't overwrite anything, it'll just create it if it doesn't exist. So this just creates that directory if it doesn't exist. Then write object to file essentially just creates the directory if it needs to, so that it doesn't get yelled at when it tries to make a file stream. Opens a new file stream to that path with filemode.create, because if we're writing the file, we can assume that whatever's there, we want to blow away. It gets passed in a function for the serialization method that it uses. This is just so that if you want to swap out XML for binary, anything like that, it's very simple. It just calls that function using the stream and the object, and then closes the stream. Read is very similar, makes a new file stream, deserializes it using the function that gets passed in, and then returns the data cast as the appropriate type. And then the functions that are actually getting passed in here are these serialize XML and deserialize XML functions, which are again very simple. You just make a new XML serializer and then call serialize or deserialize. All right. So that's data files. All right, so the last thing we'll look at is our custom assets. So essentially, these are just another way of storing data. These are actually stored as a subclass of Unity object, so you can actually edit them in Unity. You can put them in your project view, and they actually have an inspector because they are a Unity object. So this is the other example I was talking about earlier. You can use custom editors for these as well as mono behaviors. So the actual data is generally stored in the assets directory, and they need to be stored using the .asset extension. That's the only way that Unity knows that it's a Unity asset. That's not what to do. So the class that actually has the data in it should be extending scriptable object, which is a class that Unity provides for essentially this purpose. Any object that needs to be a Unity object, but not a component. Scriptable object does that. And then asset database is the class that you will primarily work with to manipulate stuff. Find assets, you can pass in essentially a filter string to look for, and this looks in every asset in the project. You can filter it based on the name of the file, the type of the file, or the class type of the file, and you can tell it which folders to look in, which is the string array. Now that will return you a list of globally unique identifiers for those assets, which for all intents and purposes, human readably are gibberish. For that, you want the GUID to asset path function, which just takes a GUID, returns the actual path from the base directory of your project. Load asset at path takes that path and will return the object that's stored in that asset. Generate unique asset path will essentially, you give it, say I want to store a file in this folder called myasset.asset, and it'll look and say there's already a myasset.asset, but I'll give you myasset1.asset. So that makes sure you have a unique one. And create asset, you pass it an object and a path where you want to put it, and it creates an asset at that location. And then from then on, if you're editing an object that you've loaded as an asset, the data automatically goes back and forth. You don't need to do any specific manipulation to change it. So a good example of something like this is if you have like a dialogue system or conversations in your game that you need to store data for. So let's go open this up. So we have a dialogue conversation class, which just stores a conversation between however many people you want. Simple, again, serializable class that just has for any element, there's a speaker and what they're saying. And then the data object has a list of these dialogue elements. And then we add a menu item in the dialogue menu to create a new one in this folder that we have specified for all our dialogue. And then we'll look at this new asset function in a second, but we just tell it where to put it, what it should be called, and we can give it an initializer. In this case, we just want to make sure that .lines is not null. Then we have a player, which is an actual mono behavior that will take one of these conversations and play it out. You just give it a text mesh, and then whenever you hit space, essentially it looks at the conversation object that it has and displays the next line with the name : text. And then we can look at asset helper for most of the interesting stuff. So this is fairly complicated. Again, I'll put all this up with all the source code, so don't worry about entirely wrapping your head around it here. Essentially, this is similar to the file stuff where we make sure that the directory exists. When we're loading an asset, we just search for all assets. In that filter string, if you do lowercase t : and then a string, it'll search for that type. So in this case, we get passed in a type, which is going to be a dialogue conversation. This would be t : dialogue conversation. And we can specify what folders we want it to look in. So in this case, we get passed in a folder path. We only want to look there. It grabs that GUID, takes the first one, converts it to an asset path, and returns it. So this is actually returns whether or not it got a value and outputs it in this out object. So that's kind of like some of the try things you might do with dictionaries. As far as creating an asset, here we just, again, give it a folder path, the file name, the extension we put on the end, and some initialization function so that we can tweak how it gets created. That is important because scriptable objects, you can't do new scriptable object. You have to use this create instance function just because of the way they're built and the way that they work with Unity. You create them this way. So this new asset function takes an initializer so that whenever we make one, we know that as soon as it gets created, we do this on it. So in this case, it's going to be initializing that list so that it's not null. Then we essentially just make sure that directory exists, generate a unique asset path given the parameters we got so that we make sure that this file gets created and isn't overwriting something else. And then we just call asset database.create asset, and it makes that asset, and then further changes that we make to it will get saved there. So if we look at this in game, we have this dialogue player, which doesn't have anything yet, but let's make a new dialogue. So again, this is just that menu that we saw in dialogue conversation. New dialogue just calls this new asset. And then you see we have this shiny asset in the dialogue folder. I did put a custom editor on this because, again, lists are ugly. So essentially it just says speaker and then what they're saying. So speaker, Ryan, Unity editors are cool. And then everyone else, shut up. And then we'll call this conversation 1. And then if we, actually let me do this the right way, then if we want to make another one, we can create a second one, call this conversation 2, add some dialogue, just one more thing. Seriously, we want beer. All right, so we can actually just take one of these assets out of our asset directory and put it right into the inspector, just like we would with any other Unity object. So we just drag that in there. The text message is already hooked up. And then if we run this, it'll actually play out the conversation. So, oh, I spelled cool wrong. Sweet. So then it does this. If I hit space, it'll go to the next one. I can't capitalize either. And then it just keeps going, but there's no more text to display. And then, again, if we want to swap it, we just grab this other conversation, drop it in here, run it, and hit place. The one other little tweak to this is that we can use the asset database to also look through all the assets in the project and find everything that's a conversation. So here we have a custom inspector that I added onto the end of the player that essentially finds all assets of type dialogue conversation, grabs the names of them, or sorry, grabs the asset paths for them, and uses the pop-up field, which is super handy. Essentially, you pass it an array of strings, and it gives you can click on it, you get a list of them, and it returns the index of the one that got selected, and then you can load that specific one right from the inspector. So if we look at this guy again, we have this pop-up down here. We've got conversation 1 and conversation 2.asset. Again, the slashes give you submenus, so since they're nested, that's how they show up. And then if I want to switch, if I want to load conversation 1, just click conversation 1, it loads in there. And if I play it, we can see how bad I am at spelling and punctuation. Not punctuation, capitalization. All right, so that is custom assets.
Question.
Yeah.
For that, and for I guess one of the previous examples of the game board, you had to click basically regenerate.
Mm-hmm.
Can you set it up to do that automatically?
Yeah, you could pretty easily do that. I just didn't happen to for this. Yeah, with that, just whenever you're setting the data, you just want the object to, in that function, regenerate itself. I actually thought I did that for the game board, but apparently I didn't. All right, so where was I? Right. So that's all the material I'm going to cover. A few other things that are kind of useful references. As I mentioned earlier, the Unity script reference is great for looking up specifics of all this stuff. Google, also very helpful. I got a lot of very good information off of there. I use it roughly every day if you forget how to do something, aren't sure how to do something, there's a lot of really great resources on Unity, Unity editors, everything. A few talks that are worth watching. Unite every year has actually had an editor scripting talk. The first year it was 2 devs from Unity talking about sort of the basics of writing editors. It's kind of similar to the stuff that I covered, but it's still a good watch. I highly recommend it. And then Unite 2012 and 2013, an indie developer that does a lot of editor scripting came in and showed some more complicated and in-depth stuff. Both of those, if you're interested in cool stuff you can do with editor scripting, are very worth watching. So at this point, if you have any questions that you haven't gotten yet, happy to take them. Otherwise, my email and everything's on here. Feel free to get a hold of me. They will be soon. I'll post a link to the meetup when they're up. Anything else? All right, cool. Thanks, guys.
Thank you.
Awesome.
I don't want to break it by unplugging things. break it by unplugging things.
Yeah, I actually have no idea. Maybe. I don't think I'm putting all this down. So, thank you. I greatly appreciate it.
No problem.
Awesome, lots of content. Like, really appreciate you putting it all together.
My pleasure.
So, yeah, so it is not raining currently, right?
It's an inspector too, don't forget.
So, because it's not raining, I think we should transition over to the bar now, because it's supposed to start raining later on. So, get you guys out of here a little earlier, start mingling over there. For those of you who don't know, we usually meet at the World Beer. It's a block this way, and then you turn right past the firehouse.